Okay, how do we decide if our p-value is small enough to reject our null hypothesis? Okay, the answer to that is before we start our hypothesis test, we're going to set a level of significance. We call that level of significance our alpha. Alpha is a value, usually it's between 0 and 10%. And the way that that value is chosen is we look at how serious our research is. So if it's super serious, like if we're interested in a bolt holding a wing on a plane, if the bolt fails, the wing falls off the plane crashes to the ground, people die. So that's a really serious thing. So we would set our alpha to be really, really small, like 1%. Okay. If we're looking at something less serious, like the proportion of people who think that Hawaiian pizza is an actual great tasting pizza, that's not a big deal if we get that wrong. So we could have a lot larger alpha. So 10% would be fine, because if we make a mistake, nobody's going to die. People might be unhappy with the pizza selection, but nobody's going to die if we serve Hawaiian pizza. Okay. So that alpha is chosen based on how serious the mistake would be if we get it wrong. Okay. So the most common alpha level, or if one's not stated in the problem, the one you should use is a 5% alpha. Okay, that's the most common one, or the one you should default to if it's not given to you in the problem. So let's take a look at that, picture the normal distribution again, and let's see kind of how that plays out with the p-value. Okay, so the way that this works picture-wise is here's my distribution, and it's centered at my null hypothesis. Okay. And I'm going to set that alpha. So suppose my alpha is set at 5%. So there's my alpha. It's set at 5%. And my p-value, I calculate my probability that I would have gotten the evidence that I got or something more extreme, given that the null is true. And that probability comes out to be about 3%. Okay, so that would be over here, because that 3% is smaller than the 5%. So here's my p-value. It's at 3%. Okay, so my p-value is smaller than my alpha. Okay, and when that happens, I'm going to reject the null hypothesis. Okay, so in other words, I have evidence that I think my alternative hypothesis is likely true. Okay, so if p is smaller than alpha, we're going to reject the null. So the other thing that can happen though, so let's put our alpha value back on here at 5%. So suppose my p-value comes back and it's at 6.5%. Okay, so here is p right here. So p is 6.5%. So in this case, my p is bigger than my alpha. If your p is bigger than your alpha, you do not reject the null hypothesis. Okay, so in other words, you do not have enough evidence against the null to reject it. Okay, so to reject, you have to have enough evidence to get past your cutoff value. So this alpha is a cutoff value. You want to be further out of the tail than the alpha is with your p-value. So if alpha is at 5%, that p-value needs to be less than 5% in order to reject. Okay, so it needs to be further out the tail. And it works the same way on the other side. So I do these on a left tail test because in our minds we think about a number line counting from left to right. But it works the same way on a right tail test. Okay, so I can still put my 5% here. And if my p-value is 2%, 2% of the right end of the tail, so this means my alternative hypothesis would have been a mu is greater than some sort of value. And that's okay. My p-value, though, is out here at the 2%. Okay, so same thing. Here's my cutoff value at 5%. The p is further out in the tail. Okay, so if I've crossed over my threshold and I'm further out in the tail, I'm going to reject the null hypothesis. Okay, so that is what our level of significance, our alpha, does. Okay, and there's the symbol for alpha. So if you haven't seen that before, it kind of looks like the letter A. It's just got a kind of like an extra tail on it. So there's it's a lowercase Greek letter, alpha. So that's what that guy looks like. All right,